Hi, can you all hear me? Awesome. So let's get started, okay? So my name is Francesco. I'm a technical manager and mobile engineer at Nubank. And today I'm going to share a little bit about how we test our application. But before that, just so I can get a feel of the audience, can we have a little show of hands? Who here has already written a test before? Please raise their hands. Wow, okay, nice crowd, a lot of people. And who here believes that writing tests can actually improve the code quality? Pretty much everyone who raised their hands before. And who here usually writes tests, like daily or in their projects? Wow, that's like the biggest number I've ever seen. Wow. So let me take a step back and tell you about Nubank, what's Nubank, and why that's so important to us. So Nubank is the leading financial technology company in Latin America. We've launched in Brazil in 2014 with a purple card, that one. Not actually that one, but you know. And we really care about diversity. So we have a really diverse team. We have over 2,300 people. Like 30% of that self-declare LGBT. And we have 43% of women in all levels of seniority and even in executive positions. And this really matters because we make our products for everyone. So our core purpose is to fight complexity, to empower people. So that's why it's important that our product is made by a huge selection of different people and that it also works for a huge selection of people. So throughout this talk, you will see examples of how we change the way we test so we can make it easier to create an accessible application as well. And right now we have over 15 million happy customers, so that's a lot. And they do everything through the app. So we don't have physical branches. We are like a neobank, as people call it. So if the app does not work, you cannot like pay your bill, so the app has to work. And because of that and our core purpose, we always had this culture of quality and testing everything we do. But most of you already know, but what are tests? So tests are a software that runs your code and attempts to verify that it's doing what you think it should do. And it's code, right? So it may have bugs. And in our case, the whole talk will be leveraging the XC test framework. So we are not going to reinvent the wheel. We're just going to showing how you can build on top of that to get like the best testing experience. And I also believe that there is a deep synergy between testability and good code design, as a lot of you do. And so why do we test, right? First and foremost, we want to avoid regressions. So you have fixed that nasty bug, and then 2 weeks later, it's back. And you're like, hadn't I fixed it? How did it come back? So that's one thing. And we also want to have more speed when we are refactoring or making changes. So we have more confidence. And speaking about confidence, the new engineers really feel safer in their deliveries. So there's this story I really like about an engineer that had just got into the company. He had like 3 weeks, I guess, and he had already shipped code to production. And I was having dinner with him. I was like, wow, like 3 weeks? And he told me, yeah, because the tests made me feel more comfortable for 2 things. First, I know that my feature is working. I know it works as I intended to, but more than that, I can ensure the existing behaviors of the application. I can ensure that the code I wrote has not broken the feature that someone else wrote, right? And we want to do that automatically because no one likes manually testing their applications every time they're going to send it to the App Store. And if you do that several times a week, then it gets even harder, and in different use cases. As I told you, we have all types of users, and we cannot just like test assuming everyone has the latest and greatest iPhone 11 Pro with the default font settings. That just doesn't happen, right? And if you want to get more into this synergy between testability and good design, there's a really nice talk I like by Michael Feathers, and I really recommend you watch it. And so when talking about tests, there's this concept of a tests pyramid that's basically like a way to help you design your test suite. So in the foundation of this pyramid, you have the unit tests, and then on top of that, integration, and then all the way on top, HUE. And basically, the idea is, the more you get to the top of the pyramid, the more integrated are these tests. The more things they test at once. And the more you go to the bottom, more isolated they are. And because of these exact reasons, the tests that are upper are slower, and when you go to the bottom, they are faster, right? And the most important thing is we want to find, and I really like this quote, the balance between thoroughness, quality, and execution speed. So that's what you're looking for, right? You want to test your application, but you want to test it efficiently. And how we do that? Okay, so I'm not going to get much deeper into that HUE part right now. I'm going to focus more on unit tests and integration tests, but we want to make sure that our code works the way we think it should. So we have a lot of things in place. And if you take a look at what I said about the difference in time, just so you can have a feel, we have right now in our native iOS code base about 7,000 unit tests and about 300 integration tests. But these 300 tests take more than 10 times longer than the unit tests to run. So you can see that really is something that matters. And then what is our testing strategy, right? So not only do we have tests, it doesn't matter. If you have a lot of tests in Xcode, but people don't know they are there, people don't press command U, it won't happen. It won't help you anyway. So the first thing we do is test before each merge. Before anything is merged to the master, we run our tests. Second, every time anything is merged, we send it to the App Store. We send it to test flight, so all the employees can test it. After that, we have the automated HUE tests, which I won't go deeper into this talk. And in the end of the day, there are sometimes your test pass, you send code to production, and it just doesn't work. So we need to have some kind of fallback, and that's why we have rollouts and feature flags. There will be a talk by Eleni tomorrow, so if you are into this, please watch it. And dive in a bit into continuous integration. So what does exactly testing before each merge mean, right? So this is a screenshot of our GitHub. So you open a pull request, and there are two things that need to happen. First of all, a code review, because as I said, test is code, and code can have bugs. And you're not going to write a unit test your test, right? So you rely on a human being to read our test and ensure that that makes sense, and a lot of other checks that are mostly more easily done by a human being than by a machine. And in the end, all your tests have to be green, and then, okay, you can merge it. And then, after that, we have the continuous integration. So this is a screenshot, right? This is the way our Jenkins pipeline looks like for when you make a small change and just impacts a few of our modules. And those tests, they have to run on actual Mac hardware. So we cannot just spin an EC2 instance and do that, because we have to be using Mac OS. And we don't want to keep taking care of a lot of Mac minis, risking someone tripping over the cables, and I mean, I don't want to do that at least. So we rely on Mac Stadium, and we use them. They give us Mac Pros in the cloud with redundant energy, redundant networking, and they just work. On top of that, we have a VMware ESXi, a hypervisor, so we can make our lives easier. And then we have these little VMs, virtual machines, and we use a software called Ansible to write playbooks that are just saying what we want on these machines, right? So we can have a reproducible state in our continuous integration system. So, I don't know, we need to install Mac and Xcode and then Ruby and Fastlane and AWS CLI. And on top of all that, we have a Jenkins client, because we use Jenkins. And then this is going to have several instances, and it's going to delegate which instance is going to run your tests, right? And the Jenkins client. So now, going back to continuous delivery. So this is the way a complete test suite looks like. So this we're testing all our modules. So we shard it, so it's faster. So right here we have 1, 2, 3, 4, 5, 6, 7 machines running in parallel. So you can have the test take a seventh of what they would take if we were having just one machine. And after that, we go the unified release, and then in the end, we send a version to test flight, because we have our employees constantly using the beta version to test and make sure that nothing is broken. And then, now, going back to the base of our pyramid, talking about unit tests, right? You're going to have a lot of this. So they focus on the individual behavior of components. And component here really is a vague term. It can mean a function. It can mean something bigger than a function. It will vary. But it's decoupled, specialized, and fast. And normally, the way we do it is we compare the output of something to what we expect what it should be and see if that matches. But real life is not always as nice like this, right? So let's give you a bit of context. So we have this screen in our application, basically from where you can refer your friends, and there is this the first button, you click, and then you input an email, and a person will receive a nice email telling them about Nubank and why they should also become a customer. So let's take a step back and think about the data structure that's powering that, right? So if we take a look just at this block, we have several channel datas, let's say like that, and then they have a type that can be email, WhatsApp, or Facebook Messenger, whatever. They have a count that for email, it makes sense, but for other things it doesn't, so that's why it's optional. And finally, whether a user can or cannot open that channel, because to invite someone by email, you need to have remaining number of invites, but to invite someone over WhatsApp, you need to have WhatsApp installed on your phone, so the rules are different for different channels. And just a simple of how these instances would look like something like this. So email count 1 can open true, and in this case WhatsApp count nil and can open false, because as you can see I don't have WhatsApp installed, so I cannot invite people through it. And so how do we test the creation of this? How do we create the channel? How do we test the creation of these channel data, right? So we have this function in our interactor that receives some things, and then depending on the channel, it creates the correct information. So the issue here, when we look at it, this function implicitly depends on UI application, right? So this function that was supposed to create something that's related to my domain is now knowing about UI application. It's depending on UI application. But it doesn't even need UI application. It only needs a small part of that, that is the ability to know whether or not a given URL can be opened. So a really nice strategy here is to extract that behavior that we want to a protocol, so let's say URL handler, that just says if a given URL can or cannot be opened. And doing that, we are able to provide to our functions with what we expect. And then we have these functions that will look more like pure functions, right? Let's talk about pure functions. So what are pure functions? A way I like to think is that they normally have a return value. You understand later why. They're not void. And they have a deterministic result. So every time you run it with the same input, you get the same output every time. And it's like math functions, like f of x is y, like x squared. 2 squared will always be 4. It doesn't matter what happens. And they usually have no side effects. That's also a thing I'm going to dive deeper. So let me give you 2 samples of functions. So the first one is Fibonacci, is a function that calculates the sum of a given sequence. And the other one is a function that saves an entity to a database, right? And the first one, as you can see, is pure, and the second one isn't. And a nice way of seeing that is whenever a function is pure, you will not lose correctness of your code if you replace its call by its return value. So if we compare Fibonacci of 1 is 1 and Fibonacci of 1 is 1, your program still does the same thing, right? But if we try to do it with this other one, my code still, yeah, 1 equals 1. But I wasn't calling this function because I want the return value, the number 1. I'm calling it because I want its side effects, right? I want it to do something and save something on disk or something like that. And we also would like to test that, right? So now going back. we can inject our dependencies, and the simplest way of injecting dependency is just like passing an instance to something. So the function does not have the responsibility of knowing how that thing will be provided. It just gets it and uses it, and that's exactly what we're doing here. And so we can refactor this usage of your application shared just to use our URL handler, and then our code is, well, so much better right now. And then testing these pure functions, I'm saying pure because otherwise the functional people will get me in the exit, and is simply you put an input and then you assert the output. So I create a mock that says WhatsApp cannot be opened, and then I expect not to be able to click the button because that's my rule, right? And then when we're talking about side effects, we have this, we like to think of like this functional core. Everything that's closer to our logic is as functional as possible. And then as we go outwards, we have a controller that acts like an orchestrator of those side effects. And in the end of that, we have this imperative shell. We are dealing with system APIs, HTTP calls, things that can fail, things that have a lot of side effects. So we put this controller in the middle just so we can have this orchestration. So when we look at this function that has side effects, right, and we want to unit test it, we already know that we can improve this. Once we look at it, we see two opportunities of making it better. The first of them is injecting the manager and the view controller, right? Because that function was implicitly knowing how to create a manager and a view controller, which is not part of its responsibility. And so once we have that, we just did the same thing we did before, but right now we can have a test that simulates a click and check if the other part was called. So we have a thing in the middle that's just like rerouting side effects, and then we can just test it. We also want unit test views because they are really important. And this allows to validate the layout is working in several use conditions. So we do that by using screenshots. This is the way it would look like in the file system. And it really helps when interacting with designers, so we can sit with them and show them the way the screen looks and see, is that really what you wanted? And then just get to the pixel perfect thing that we wanted. And it also avoids unwanted modifications of the layout. So let's say you change an extension of UI font somewhere and you end up breaking the entire application. This way you will know. And the thing I like the most about it, it's agnostic to view hierarchy changes. So you can like start using a stack view and your tests won't break unless you have actually broken the layout, but that's another story. And it allows validation of accessibility, especially in our use case. We've done our tests in a way that we can inject content size categories and ensure that we can test the same view with different content size categories and that it looks good for all our users. But how do we do that, right? Testing a component that does a lot is hard, and by default, our views do a lot. So this is a bit of an abstract idea, but in order to test layout independently, we just have to, as we've done before, divide the responsibilities, decouple behaviors, and then get this monolithic screen, and we've exploded it in our architecture, so we can have several components that all of them are independently testable. So if you want to learn more about this, check this Medium post. It goes much deeper into our architecture. And basically, once we have this view, whose responsibility is just showing a layout, we can, for instance, exercise all sizes of a given component. Say, let's see how a screen looks on all iPhones. Or we can exercise, as I said before, the content size category, right? Does this look good in the accessibility extra large? Well, now we know it does, right? And we also want to exercise different states. But how do these tests look like? So basically, as we have those view models in our architecture, we can just grab a view, bind its view model, take a screenshot, and see how it looks. So we have this little helper function that we just assert that and validate to us that everything's working. So here we have the different possibilities of state that screen can have, and then we just validate that they are OK. So for each one, we try to assert if they are working as intended. OK, so that's pretty much unit tests. And now for integration tests. As I said, they are more integrated. And this, some people like to call it UI tests. But since we are end-to-end tests, we don't call it end-to-end tests because we start them with a given route that's not accessible by the end user. So we start in a given screen and test from that. And after we started it, it's the real app flow with little to no modifications, and the requests are mocked or stubbed internally. So the way this looks is you have our app, and then you have the user giving an input that's going to be input by Kif, keep it functional. It's a library that uses, leverages the accessibility API, so we can also have more confidence in that. And then we use OH HTTP stubs to stub requests, and then Kif, yay, it's happy because the test has passed. So this is a sample screen recording of our tests running. This is like the login one. It's testing several different cases, like the backend is not working, your device is not authorized, your password's wrong, your password's right. We are testing a lot of stuff. And here we have another one where we're testing like reordering these things at the bottom. So we are trying to reorder it by clicking and dragging. We are trying to reorder it by the table view and so on. And the way we write this code, what I like the most about these integration tests is they're so easy to write, right? So we just say each action that we want to do. And a thing I like is the Kif has, you say what the interaction we want to do, and there are implicit assertions. So here I say tap view, and if the view does not exist, my test will fail. So I don't have to keep verifying, I just say everything that I want to happen, and if a step does not work, it just fails. And so what you do? You saw that the video was quite fast, right? We did not speed up this video. What we do, we actually speed up the animations in our layer just so our tests run faster. And that way, we can have more and more engineers coming to our team without having to increase a lot of the time that it takes for the test to run. And as a recap of what I've covered, so we've talked about the tests pyramid, right? We want to have a lot of unit tests. We want to have some integration tests and a couple or a few end-to-end tests. That depends on your business. And about writing testable code. So in the end, we're just wanting to avoid implicit dependencies by injecting dependencies and use pure functions or things that look like pure functions as much as possible so it's easier to test. And a decoupled architecture, right? We designed our architecture with testability in mind. So, of course, that helps us a lot. And I've also covered automation. Automation saves a lot of time, especially if the team growing and growing and growing. And I've mentioned some tools. The slides will be available later, but I didn't mention, but you probably saw Boars. It's a queue for merging several PRs at once. We use MaxStadion with VMware and Ansible and Jenkins and Fastlane. And we are back at using Bluepill. We had stopped using it, but then we got like haunted by all the simulator crashes, so we came back to it, and it's helping us a lot. About testing frameworks, the ones I showed to you are, we actually have our own fork of this that before Uber took it, it was a Facebook, and then Facebook stopped updating it. We made our own internal fork that adds a lot of accessibility stuff and things that work for our domain, and Uber had made an awesome job of creating a more non-opinionated version of this and making it open source. And we also use Kif, Keep It Functional Framework, and OH HTTP stubs. So that's it. Thank you.
All right, we have time for 3 questions. Oh, wow, a lot of raised hands. Okay, I'm going to pick. So this guy, oh, just take my mic.
Hey, thank you. So I was wondering how much test flakiness do you have, and how do you deal with it?
Yeah, this is a really big problem we are having. Basically, the question was about test flakiness. Test flakiness is when you have a test that sometimes it passes, sometimes it doesn't. There are several reasons why this can happen. We usually try to find the biggest reasons and then just solve all of them at once, because we have flaky tests that depend on networking. These are the easiest ones to catch. We just turn off the network and run the tests. Anything that breaks is flaky. We also have tests that break because of dates, because of locale and stuff like that. So sometimes what we do is ensure we have a better cleanup before and after our tests, and that we are actually testing what we want, that we're not making a test that's like more integrated than it had to be, and that's breaking for random reasons. That's another reason why tests become flaky, because the test implicitly depended on something that changed, and then it broke the test. So, but yeah, that's a big problem, and all the time we have to keep checking and fixing this flaky tests. If anyone has like a tool or anything to help with that, we would love to hear, because that's a real pain.